So guys, we are now set up and we are ready for our next session. Our next session is around emerging technologies in testing automation. Now, automation is the buzzword around for everybody, and we hear it a lot, but we are going to talk today about testing automation. So emerging technologies are central to the digital transformation that is underway, not just here in the region, in India, as well as globally. These emerging technologies are enhancing the quality of applications and reducing time spent on testing of software and increasing the efficiency in the process. On that note and on that topic, we have today two gentlemen here, Rajeshwar and Deepak, and they represent Tietoevry, and they are going to talk about how you can bring in emerging technologies into this process. So on that note, over to you and take it up from here. Thank you.
Thank you.
Thank you. Thank you so much for the great introduction. Okay, so I would like to start our talk by asking all of us a question, why we all are here. Okay, and probably all of us would answer, we all are here to understand what is happening around in the industry. And why we want to understand that? We want to understand that because we want to stay relevant. So in next 20 minutes or so, let's try to stay relevant and see what are the emerging technologies in test automation space. Okay, so we are going to talk about hyperautomation. We are going to talk about hyperautomation in testing, how the tools and platforms are reacting to the hyperautomation space. We are also going to talk about some part about cloud testing, API first approach and how to test that, containerization uses in testing, and some other emerging trends. Okay. Okay, so this is a graph published by Gartner, which basically talks about how the testing is evolving. So according to this, we are already in the era of value streams, and this will be dominated by AI augmented testing. So what typically we expect is our applications are going to get complex, and the rate of change is going to be very high, right? And we expect with the new age technologies and other approaches that are coming up, the delivery cycles will typically go down. And we also expect that testing efficiency or efficacy will go up, and let's see whether it's true or not. Okay, hyperautomation in testing. We all might have heard hyperautomation in terms of processes, but let's see what it means in terms of automation testing. Okay, so we all know how an enterprise application look like, and now enterprises are adopting composable architectures, which basically means our applications can be assembled, reassembled, expanded in order to deliver innovation, right? Innovation and to cope up with the rapidly changing demand or accelerated business changing demands, okay? But what that essentially means for us as an automation tester, I have to test rapidly changing business scenarios which might span across multiple technologies, multiple platforms built by different vendors or companies. I have to deal with a lot of data which might be highly structured or highly unstructured, right? The degree of automation will be varying, because with the introduction of these technologies like artificial intelligence, our applications are also going to get smarter, right? So we need a smarter way of testing these, right? So what approach we need to take? We need to take a business-driven, disciplined, platform-based approach to test automation also, with orchestrated use of heterogeneous tools and technologies like RPA, AI, and ML. So understanding the challenges, let's see how our industry is reacting to this. Okay, and we all understand what are the different challenges in scaling automation. Release frequency, time and effort required to build our test cases on different platforms. Of course, the automation skill set is a challenge. And what it collectively means that the rate of automation is typically very low, and it's typically with high maintenance cost. So how the platforms are reacting, or how the industry is reacting. So first approach we are taking is low-code, no-code tools, which basically means very little programming knowledge would be required to develop the test cases, right? Initially, when these tools came up, they came up with very basic set of capabilities with libraries like Selenium and other libraries for testing APIs. But with the evolution of technologies like artificial intelligence, now what they are doing is, or the platform is capable of, is using computer vision and machine learning. They are capable of identifying your screens and elements as a human eye will do, right? And with the help of complex neural networks, they can perform operation as well. And I'll talk about it more. And using natural language processing, we can write test cases or test scenarios in human readable language. Another feature that these tools or platforms are coming up with is pre-built behaviors and assets. So typically we use applications like from different companies, built by different companies and vendors. So in collaboration with these companies, they release pre-built behaviors or assets, so we can readily download these assets from the marketplace, and we can automate quickly, right? And what advantages does these tool or this approach provides us is, of course, we left shift the functional testing and API testing, accelerated test design, simple script creation, and resilient script, as the scripts are not based on the physical properties of element. They are identified using computer vision and machine learning. The scripts or automation scenarios can be self-healed using this, right? And of course, the reduced skill set. So we just talked about the functional aspects of it, but these technologies are changing how we are doing performance testing or performance engineering and security as well. If I talk about performance engineering, the observability tools that we have these days using AI can predict performance anomalies way ahead of the incident, when the incident actually happens, right? The models can generate synthetic CAN data for us, which can be used for your performance engineering practices. If I talk about security, there also the right shift approach. If we talk about, there are applications like which is like running in production, which is real-time application protection applications, which can intelligently detect the attacks happening on the production system, and they can avoid it. Okay. And this is an example of low-code, no-code tool that we have built in-house in Tietoevry. And this, using this, basically, we are creating our test cases, functional test cases, and these same test cases are being used for performance and security testing as well. Okay, so those of us who love programming, and what we do typically is we go to Google and search for code, we find the relevant code and try to create our application, right? So there are intelligent, plugins that are coming up, which we can directly use in our IDEs, and which can intelligently create code for us. I'm trying, so here you are seeing on your screen, there is a demo. It's built with code, Git Copilot, but there are other tools like Tab9 and all, which can be utilized for the same purpose. So here it's using natural language processing, reading the comment that I have provided, and suggesting me the context relevant code. And if you see, now it will be creating an entire class for me looking at the comment. So a class will be created. See, so how awesome is that? right? So of course, there are other toolings which can, or other plugins which can uh, liberate us or from generating unit tests, but I'll not talk about that. It's kind of based on similar thing. With that, I'll hand it over to Deepak.
Thank you, Rajeshwar. Okay, we had a wonderful panel discussion in the morning on API strategies. Let's see now what that means from the test automation perspective. API first is an emerging technology trend which treats API as its own product. What happens in product development? We first try to understand consumers' needs. Then we develop product design, and then we validate it from the consumer's perspective. Same thing happens with API first. We first try to understand consumers' need. Then we develop API definition, not the actual API, just the API definition. And then we test it if it meets consumer expectations or not. Now, what this means from testing perspective? This is a significant shift left in testing approach. With API first, the contract integration testing needs to start even before development team starts with the coding. That's a significant change and shift left in approach. So there are two challenges here which testing needs to address. Let's see which are those and how those are addressed. So first, I write my API definition using API definition tool, which automatically generates API definition JSON. After this, I write my consumer integration test specs and my mock API service. And when I run these test specs against the mock API service using the tools like PACT, it automatically generates interaction contract JSON, which has all the interactions between these two. After this, what I do is, using mock validator CLI, I validate this contract JSON against my API definition JSON. And if this fails, that means either my API definition has some flaws, or there is some flaw with the way that my consumer integration test specs are written. In any case, I rectify that and make sure they both are in sync with each other. It is only after this that I write my actual API service and my mock consumer, which directly utilizes this interaction contract JSON, which was used in consumer contract testing. And now, when I replay all these interactions against my actual service, and then if this passes, that means I'm assured that my API is in sync with what my consumer is expecting, and so is my API definition. It is only after this that I write the actual consumer and do the full-fledged integration test. Moving on to the next topic, which is cloud testing. When we say cloud testing, we are here referring to testing cloud native resources. Now, there are three ways in which I can test my cloud native resources. The first one is resource group verification, where I can test how my resources are created and configured. I can do this immediately after my resources are created, or I can do it even before the resources are created using the infrastructure as a code template checker. So this was the first one. Second one, using Cloud Monitor, I can test how my resources are working after being created. And the third one is using cloud policy. I can check the compliance of my resources against standards. Now, these standards could be international standards, national standards, or custom standards laid down by my company. Now, let me give some examples. If I take an example of SQL Server, resource group verification will tell me if auditing has been enabled on my SQL Server or not, backup has been enabled or not, transparent data encryption has been enabled or not. Cloud Monitor will tell me how is my database transaction units consumption, or is there any excessive wait time for execution of my queries. Then if I take another example, let's say in case of app service, resource group verification will tell me whether HTTPS has been enabled or not, or monitoring will tell me if there are any failed requests or not. And if I take one more last example of virtual machine. In case of virtual machine, verification will tell me, let's say for example, if a remote connection has been restricted from the internet or not. Or monitoring will tell me how is my CPU resource consumption, how is my memory consumption. And then moving to the last part, which is cloud policy. So here, it will tell me how is the compliance of my resources against international standards like ISO 27001 or CIS, or national standards like US HIPAA or Australian government, Canadian federal, UK official, or any of the custom standards defined by my organization. Here, the best part is that all of this, which I just mentioned, can be completely automated and integrated into my DevOps pipeline as quality gates, so that I can assure that all these tests which are defined by me automatically pass before I release anything to the production. If I give an example of Azure, for IAC template checker and resource group verification, we have Azure Security Kit. For monitor, we have Azure Monitor, and for policy, we have Azure Policy. So this is how we can do the cloud testing of our cloud native resources. Thank you. Over to you, Rajesh.
Thank you. So, moving next. So, containerization or the use of virtualization technologies in testing. Okay, so this is kind of interesting, and previously in development we all are aware where and how the containerization technologies can be used, right? But let's see how this can be used or is being used in testing. So there are multiple use cases, but I here try to collect few so that we can build some context. First, so basically we all understand what containers are. Containers are lightweight, scalable, isolated environments. So let's see how we can use. So the first use is you can use them in building your automation frameworks. So towards the right, you are seeing an automation framework that we have built in-house. So basically it's an security framework which we are using in our CI pipeline. We are performing dynamic application security scan. So it's built on top of Ubuntu, and it uses ZAP and JMeter, and entire networking stuff is handled there. So typically when you try to execute test cases, we need proxies and all. So everything is configured there. So what advantages it had bring to us is like this is portable. Our multiple teams are using it, right? These are lightweight. We don't need a heavy infrastructure to be set up for security testing. Highly reliable, right? So depending upon the context and the usability of these containerization technologies, we can also come up with the frameworks like this. Okay. So another part, we are mostly dealing with when in automation testing, we are dealing with a lot of tools like reporting tools and all. So what trend I am seeing is more or more these kind of tools like dependency track or defect dojo, they are all coming with this containerized deployment. So that is where we are also finding that more and more use of containerization or cloud-based technologies are being used. Execution dependencies. We all know how the era where we were struggling with setting up execution dependencies for running our functional tests, like set up take a machine, set up Selenium grid, maintain those grid. All those kind of hassles can be taken care by these lightweight containers. So here we can see on a screen, we are using test containers, and you can spin the container from your test code. It will spin up a container for us, execute the test, and it will report back to us and destroy the containers. So it basically removed the dependencies from what you say, setting up my execution labs, right? Also, another way these containers are being used is to test dependency, integration testing. So you can put your dependency in the container and you can run your integration test very easily. So it created a container, it destroyed it, and then reported back. Yeah? Some of the other trends that we are seeing, like adaptation to chaos engineering and left shift in non-functional testing. Some of us might feel that these are becoming mainstream, but if we are not already doing it, please try to adopt these practices. Chaos engineering, try to break your system in, if not possible in production, try to break them in pre-production system by introducing faults, run a lot of experiments, and try to test the resiliency of your applications. Left shift non-functional testing, and we had a session on DevOps and security previously as well. But if I talk about security, try to bring in security in every phase, do threat modeling, performs SCA, SAS, DAST, penetration testing, and as I said, you can also implement runtime application protection in productions, right? Talking about performance testing, you can start with the single user test, bring in your performance early, monitor the trend lines, bring observability across every phase in CI cycle, right? And also you can, using these smart tools that I talked about, you can also monitor performance of your application and get the anomalies, performance anomalies very early in the phase. I think, yeah, we can take some questions if you have. We still have time, right?
Yes, any questions?
Yeah.
Yeah.
Yeah, okay. Thank you, guys.
Thanks, everybody.
Thank you so much. Please stay with our people. Thank you so much. We want you on the dais, please. So, as we have been informing, we are planting saplings on behalf of each one of you. So So we'd like to give you a certificate for that and also a small token of our gratitude. Thank you. Thank you so much. Thank you. Your laptop. Rajeshwar?